The IEE Wiring Regulations BS 7671/2018, also known as the Wiring Bible, contains a comprehensive list of residential and industrial voltage and frequency options for every country in the world. An article on the IET website details different electrical voltages and frequencies used around the world. Europe has 480 volts 3-phase 50 Hz as a standard voltage option. However, it is not commonly used in residential settings. It is more common in industrial and commercial applications. The International Electrotechnical Commission, or IEC, provides a world map of electricity. The National Electrical Code, or NEC, offers a voltage and frequency chart. Electrical systems around the world differ significantly in voltage and frequency. These variations are rooted in historical developments, economic considerations, and technical standards adopted by individual countries or regions. Understanding these differences is crucial for ensuring the safe and efficient operation of electrical equipment across borders. Voltage refers to the electrical potential difference between 2 points in a circuit measured in volts. Common voltage levels for residential use include 120 volts in North America and parts of Japan, and 230 volts in Europe, Australia, and much of Asia and Africa. Industrial voltages are typically higher, such as 208 volts, 240 volts, 480 volts, and 600 volts to accommodate the greater power demands of machinery and equipment. Frequency refers to the number of complete cycles of an alternating current, or AC, waveform per second, measured in hertz. The two primary frequency standards are 50 Hz and 60 Hz. North America, parts of South America, and some regions of Japan use 60 Hz, while most of the rest of the world uses 50 Hz. The choice of frequency affects the design and performance of electrical equipment, particularly motors and transformers. The IEE Wiring Regulations BS 7671 is a widely recognized standard for electrical installations in the United Kingdom and other countries. It provides detailed guidance on the design, installation, testing, and inspection of electrical systems to ensure safety and compliance with regulations. The IEC is a global organization that develops and publishes international standards for electrical, electronic, and related technologies. Its world map of electricity provides an overview of voltage and frequency standards around the world. The NEC is a widely adopted standard for electrical installations in the United States. It provides comprehensive requirements for the safe installation of electrical wiring and equipment. Different voltage and frequency standards compose challenges for international trade and travel. Electrical equipment designed for one voltage or frequency may not operate correctly or safely in a region with a different standard. Adapters and converters can be used to accommodate some differences, but it is essential to ensure that the equipment is compatible with the local electrical system. In addition to voltage and frequency, other factors to consider when dealing with international electrical systems include plug types, wiring practices, and grounding requirements. These aspects can vary significantly from one country to another. Firstly, voltage standardization efforts aim to reduce the number of different voltage levels used around the world to simplify manufacturing, reduce costs, and improve the compatibility of electrical equipment. However, achieving complete standardization is a complex process due to the existing infrastructure and economic considerations. Secondly, frequency standardization efforts face similar challenges, as changing the frequency of an electrical system would require significant infrastructure upgrades. Thirdly, many countries have adopted specific voltage and frequency standards based on their historical development and economic conditions. These standards are often enshrined in national regulations and are difficult to change. Fourthly, the IEC and other international organizations play a crucial role in promoting harmonization of electrical standards. Their efforts help to facilitate international trade and ensure the safe and efficient operation of electrical equipment worldwide. Fifthly, engineers and technicians working with international electrical systems must be aware of the different voltage and frequency standards and the potential hazards associated with them. Proper training and adherence to safety regulations are essential to prevent electrical accidents. Sixthly, when selecting electrical equipment for international use, it is crucial to check its voltage and frequency compatibility. Some equipment is designed to operate at multiple voltages or frequencies, while others may require adapters or converters. Seventhly, it is also important to consider the power consumption of electrical equipment when using it in a different country. The local electrical system may not be able to supply enough power to operate high-wattage devices. Eighthly, electrical codes and regulations vary from country to country, so it is important to familiarize yourself with the local requirements before installing or using electrical equipment. Ninthly, grounding practices also vary internationally. Proper grounding is essential for electrical safety and can help to prevent electrical shock. Tenthly, it is always best to consult with a qualified electrician when working with electrical systems in a foreign country. They can provide guidance on local regulations and best practices. 480 volts 3-phase is a common voltage for industrial applications due to its ability to efficiently power large motors and equipment. In Europe, while 230 volts single-phase is prevalent in residential settings, 400 volts 3-phase is also widely used in commercial and industrial environments. The 400 volt system is derived from the 230 volt single-phase supply and provides a balanced 3-phase power source. The frequency of 50 Hz is the standard for most of Europe. Equipment designed to operate at 50 Hz may not function correctly or efficiently at 60 Hz and vice versa. This is because the frequency affects the speed of motors and the impedance of transformers. The IEC provides a wealth of information on international electrical standards and best practices. Their website is a valuable resource for engineers, technicians, and anyone working with electrical systems around the world. When designing or installing electrical systems in a foreign country, it is essential to consider the local voltage, frequency, and grounding requirements. Failure to do so can result in equipment damage, electrical hazards, and non-compliance with regulations. Electrical safety is paramount when working with any electrical system regardless of the voltage or frequency. Always follow safe work practices and use appropriate personal protective equipment, or PP. Understanding the different electrical standards around the world is crucial for ensuring the safe and efficient operation of electrical equipment across borders. By following best practices and consulting with qualified professionals, you can avoid electrical hazards and ensure compliance with regulations. Electrical systems are a critical part of modern infrastructure, and understanding their nuances is essential for success in a globalized world. Always be aware of the potential hazards and take necessary precautions to protect yourself and others. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or engineer before working with electrical systems. Electrical codes and regulations are constantly evolving, so it is important to stay up to date on the latest requirements. By staying informed and following best practices, you can ensure the safe and efficient operation of electrical equipment in any environment. The IEE Wiring Regulations BS 7671/2018 is a comprehensive guide to electrical installations, covering a wide range of topics, including wiring methods, protection against electric shock, and electromagnetic compatibility. It is essential reading for anyone involved in the design, installation, testing, or inspection of electrical systems. The NEC provides detailed requirements for electrical installations in the United States, covering everything from wiring methods to overcurrent protection. It is widely adopted by states and municipalities and is considered the gold standard for electrical safety. Electrical standards are constantly evolving to keep pace with technological advancements and changing safety requirements. It is important to stay informed of the latest developments and to update your knowledge and skills accordingly. The electrical industry is a dynamic and challenging field, but it is also essential for modern society. By working safely and responsibly, you can contribute to a more sustainable and reliable electrical infrastructure. The 480 volts three-phase system is often used in large commercial and industrial buildings to power lighting, heating, ventilation, and air conditioning or HVAC systems and other heavy-duty equipment. It provides a more efficient and cost-effective way to distribute power than lower voltage systems. The 50 Hz frequency is common in Europe and other parts of the world. It is a legacy of the early days of electricity distribution and has been maintained due to the significant infrastructure investment. While there are some advantages to 60 Hz systems, such as slightly smaller and lighter transformers, the cost of converting existing 50 Hz systems would be prohibitive. The choice between 50 Hz and 60 Hz is often a matter of historical precedence and economic considerations. Both systems can provide reliable and efficient power distribution when properly designed and maintained. Electrical safety is always the top priority when working with electrical systems. Always follow lockout-tagout procedures before working on any electrical equipment. Use appropriate PPE, such as insulated gloves and safety glasses. Never work on live electrical circuits unless absolutely necessary and only after taking all necessary precautions. Electrical accidents can be serious or even fatal. By following safe work practices and using common sense, you can significantly reduce the risk of electrical injury. Electrical systems are a complex and fascinating subject. By learning more about them, you can gain a better understanding of the world around you and contribute to a safer and more sustainable future. Always consult with a qualified electrician or engineer if you have any questions or concerns about electrical systems. They can provide expert advice and guidance to ensure that your electrical systems are safe and reliable. The information provided here is for educational purposes only and should not be considered a substitute for professional advice. Electrical work should only be performed by qualified and licensed professionals. Always follow all applicable codes and regulations when working with electrical systems. Electrical safety is everyone's responsibility. By working together, we can create a safer and more reliable electrical infrastructure for all.